Hello, everyone. Somewhere along your computer science journey, you will run across the mean, median, and mode algorithm. In fact, you may have already seen it somewhere before. The mean is the average of the data set, or the mean average of a data set. The median is the middle value of a data set, and the mode is the most frequently occurring value within a data set. Here is an example from HackerRank, where they are asking you to extrapolate the mean, median, and mode from a data set. Here's another example from LeetCode, where they are only asking you to get the mean average from an array of numbers. In this video, what I would like to do is teach you how to extrapolate the mean average value from an array of objects. We will start out with a very trivial example by writing a very basic function, and then we will increase the level of complexity very slightly. We are given a JavaScript array of objects, and inside of each object there is a make property which will contain the make string for 4 different vehicles: Honda, Toyota, Ford, and Chevy. Each object also contains an MPG property with a number value. The MPG will represent the miles per gallon for each make of vehicle. Of course, this is just made up data. Now, our objective would be to write a function that will take an input array and the make string as its parameters. You read the JS doc that I provided here, okay? The vehicle array would be an input array, of course. And then the make string represent each string in the make property, okay? And then it will return a number array with a single value in it. So if I were to invoke this function, which will accept the vehicle make basic here, this array here, and the string Honda, it will return 20 in the single element array here because Honda has an MPG of 20. Conversely speaking, if I type in Toyota, then it will return an array with a single element of 25. Okay. Now, if I were to enter a make of vehicle that is not inside of this array, I need to return a message to the end users, something to the effect that vehicle not found. If you were writing a function like this as part of a technical interview, some of the initial things to consider are to make sure that you understand the instructions that the tester has given you. Make sure that you understand exactly what it is that they want you to do, and to ensure that the tester has provided you with the proper data structure in the correct format that you need to write your functions. And then afterwards, what I recommend doing is to think about edge cases, think about how you would handle basic errors. For example, I mentioned earlier that what if the end user were to type in a make of vehicle that is not inside of this data structure? Okay, so for that, what I recommend you do is to think algorithmically, step by step. So basic error handling. Okay, so what does that entail? Well, you could have a case where you're missing arguments at invocation time, right? One of these could be, one of these args could be missing at invocation time. you don't have to do anything fancy here, just very basic error handling, okay? And then if you look at the example I mentioned earlier about for Tesla, well, what if they were to enter a lowercase t or lowercase h or lowercase f for T for Toyota, etc., right? So those type of things, okay? And then if we find the vehicle inside of the data structure, then we can do stuff with it, okay? And then if the vehicle is not found inside of the data structure, we can just go ahead and return a user-friendly message like on line 37. So you think algorithmically in terms of just basic error handling, you find a vehicle, do stuff, it'll help calm your nerves in these type of technical interview. If you're a rock star, and obviously you don't need to watch my video, but if you're a working adult, you know, and you're juggling life and work and children, all of that, and family, then this type of a video will help you practice and to help you calm your nerve and do better during the technical interviews. Now that we have this rough outline in terms of algorithm, let's go after the low-hanging fruit. Let's go after the easiest thing to do first. So we know that if the vehicle is not found inside of this data structure, then we can just return a simple message to end user. In terms of error handling, especially in the context of the coding interview, we can very easily go down a very deep rabbit hole, and we can spend a lot of time handling every imaginable, conceivable scenario, okay? But we only have a limited time for this video as well as during a live coding interview. So what we could do is we can just handle a very basic error scenario, just to let the interviewer know, let the tester know that we are thinking about it, okay? So let's have a very basic control flow here where we check to make sure that, if they invoke this function without the input array or without the make string, then we need to throw a very simple error informing the user that the function was invoked without the required arguments. Okay, so let's add a real basic control flow. So if not vehicle array, or we'll be missing the make string, then I'm just going to add curly braces in here for clarity. You don't technically need to add the curly braces. We're going to throw a simple error, just something like that. Just to be clear, what I'm doing with the constant on line 33, the sanitized make string constant, all I'm doing there is lowercasing whatever the end user enters for make string. And I'm about to use that constant here shortly. So on line 35, I'm saying that I need to do stuff if the vehicle is present, okay? And so I need to check to make sure that the vehicle that the end user enters as a string exists in the input array. Okay, let's make a little comment here. So we're gonna check to make sure that the vehicle exists in the input array. Okay, and let's create another constant here. It will return a Boolean, so let's call it is vehicle present. Like a lot of things in JavaScript, there are multiple ways to do things. My approach would be to use the native JavaScript array method called sum. And we can call sum, there's the documentation for it. We can call sum to make sure that the string, the make string, exists in the input array. Okay, this is a very basic check. Again, this is a Boolean, we'll return a Boolean value, so I'm naming it as such. So like I said earlier, I have a lowercase the input make string that the end user will enter. Okay, and then when I pull out the make from the input array, in this case this array here, I will lowercase this value as well. Okay, again, there are multiple ways to do this, but this initial brute force approach would be the fastest during the course of a coding interview. Of course, you can always refactor this later on as well. Okay, so basically I'm just doing a comparison check here, and of course sum will return a Boolean true or false. We are going to use another control flow in the form of an if statement. So we are going to check this Boolean constant here, is vehicle present, which returns a Boolean. If that constant is truthy, then we are going to create a filter that will filter the input array for the make string that the end user typed in. To filter the input array for the make string that the end user entered, I'm going to use the JavaScript native array .prototype.filter function, which takes a predicate. And the signature for that predicate function will look very similar to the predicate for the sum function. Essentially what I'm doing here on the left-hand side of the identity operator is that when I pull out the make from the input array, I'm going to lowercase that, which will match the lowercase value from the end user input for the make string as the second parameter. Okay, that's the reason why I lowercase this up here on line 33. Okay, so we're just doing a comparison check there. So if I were to log out filter vehicle constants right now, it will return a data structure that looks like this here, starting on line 59. It will return the make and the MPG as an array. Okay, because obviously the filter function returns an array. In this case, if the end user were to type in Chevy, this is what it will return. Okay. Now that we have a constant which holds an array with a singular object in there based on the make that was specified by the user, we can use another JavaScript higher order function on arrays called map to map out the mile per gallon and return the singular value inside of an array. So on line 47, I've declared another constant called average MPG, and then since filter vehicle is an array, I can call map on it. And then return the average MPG. Now, I'm separating out these two arrays, these two constant, to show clarity of thought. But certainly, you can chain map to this array, filter array here, and then you can rename this to average MPG and then return it. But to show clarity of thought, especially during a technical interview, I've decided to separate out the two functionalities. Now, to test out our function in the Chrome browser development tool, I went ahead and console out the function twice, one with Honda and then one with Tesla, which yielded 20 MPG, because you look at the data structure, Honda is MPG of 20, and of course with Tesla, because Tesla is not part of the array, it returned vehicle not found. So let's try a lowercase Ford, okay, and for here let's do Porsche and see what happens. Okay, and so for Ford, it should return 26, which will get 26 there. And of course, Porsche is not part of the array. Now we have a couple of changes to the requirements. First, the shape of our data structure has changed. We now have a nested array inside of the object, inside of the array. The nested array is the models array, which contains nested objects containing individual models for each make. For example, for Honda, we have the Civic, Accord, and Pilot. For Ford, we have the Taurus, the F-150, Mustang. Okay, for the Chevy, it's very simple. You only have one model there, the Suburban. So the shape of the data obviously has changed. In terms of the return value, that's changed also. So now the function, what I want out of the function is to calculate the average for each make based on how many models there are. So essentially, what we want to do is we want to add up the MPG for each individual models for each make, and then divide that by the number of models in each make. Okay, so for example, let's take Toyota. What I want the function to return is the MPG for each of these models inside of the Toyota object. Okay, so I want the average of the average MPG for the Corolla, Camry, and Highlander, and I want to return that value to me as a whole number. Okay, as a whole number. Because you look at the in the US, if you look at the MPG value published by the EPA, they tend to be whole numbers. Okay, so the rules now is exactly the same as it was before. Before you start writing code, make sure that you understand what the requirements are and that the tester gives you the data structure that you need to work with in the correct format. Okay, and then you want to make sure you understand the requirements, obviously, and then think about edge cases and the error checking. Just keep the error checking very basic, like you did before. Essentially, you just need to refactor the code to handle the nested objects and to do a little bit of math. Okay, you can pause the video now and try to come up with a solution on your own, and then I'll come back with my solution. Like I've said before, there usually are multiple ways to do one thing in JavaScript. The route that I decided to go would flatten out this array here, this nested array here, is to use a native higher order function in JavaScript called flatMap. The flatMap, like I said, is a higher order function in JavaScript, and so it takes a predicate function just like map and filter. So since we have this models nested array in here, I flatten out this array here by calling flatMap and getting out the models. So the result of this call will give us a data structure, or an array in this case, that looks something like this, starting on line 73. So when I chain the map function to the flatMap, again, when I call flatMap, I get this array of nested object. Okay, so when I call map on it and get the MPG out, I will get a data structure that looks something like this, starting on line 70, an array with all of the MPG for each model. So now I need to divide the total, the sum of this array, by the number of elements. Okay, and because of that, this constant average MPG for me, it doesn't make sense for me anymore. So I'm going to rename it to total models MPG. And of course, in the real world, you should name it to whatever makes the most sense to you. So now the signature of the constant average MPG will change quite a bit. Since total models MPG will give us an array that looks like this. In this case, there's just 3 elements, but certainly in the future, there could be a dozen elements in there, right? So now the constant MPG will be the result of adding all of the elements in this array, okay, added them together, and then dividing it by the length of the array, and then parsing it to return the whole number. Because the total model's MPG constant on line 60 is holding an array with different values in there for MPG, I can use yet another native JavaScript array higher order function to sum up, to get the sum of each element in the array. And that higher order function is called reduce. I'm pasting this function in so I can have more time to explain how reduce works in JavaScript. So the reduce function itself, the higher order function, takes 2 arguments. The first of which is the callback or the predicate function. The function itself is an argument. And then the second argument is the initial value. In this case, I specify 0, or the 0th index for this array here. Now, the predicate function itself takes 4 arguments. The first 2 are required. So therefore, I will focus on the first 2. Now, the first argument is always the accumulator, and the second is the current value. Now, you can call these arguments whatever you'd like, A, B, whatever, but the order has to be correct. Okay, so the accumulator always goes first, followed by the current value. Because the JavaScript reduce higher order function can be kind of confusing at first, I decided to take a little bit of extra time for sidebar to go into it a little further in depth. So let's start out with a basic numbers array with 0, 1, 2, 3, and 4 as its individual elements. And if we were to call reduce on this to add the accumulator to the current value. Again, the accumulator and the current value are the required arguments inside of the callback function of reduce. Okay, and of course, the index and the array itself are optional arguments inside of the callback function or the predicate function of reduce. Okay, so again, so let's say if we were to add call reduce to add the accumulator to the current value. Okay, so on the first pass, on the initial pass, the accumulator is 0, right? 0 here. And the current value, the next value is 1. Okay, so if we were to add accumulate the current value, okay, 0 plus 1, the return value, of course, is 1. Okay, and on the second pass or the next pass, the accumulator, therefore, would be the value of the return value in the first call, which is 1. So on the second call, the accumulator is value is 1. And the next value, also known as the current value, is 2, right here. So we add 1 plus 2, okay? That's equals to 3, okay? So the result or the return value of the second call is 3, okay? And now on the third call, again, because the accumulator on the third call is the value of the return value of the previous call, which is 3. Now the accumulator is 3 on the third call. We start out with that. And then we go to the next value, which is the current value, which is 3. This element right here, okay, 3. So we add 3 plus 3 is 6, okay? So the return value of the third call is 6. So therefore, the next call, or the fourth call, the accumulator will be 6. Okay? And the current value, by this time, the current value will be at this position here. Okay? At that position there, which is 4. So we add 4 to 6. Okay? Which will give us 10. Okay? So now we're done because we've gone through every single one of these elements inside of this array to reduce all the element, in this case, they're all numbers. So we're reducing all these values to be equals to 10 because we're just adding them up. So now that we have the sum of this array, we need to divide it by the number of elements inside of this array. And we can do that by calling the array itself and the length property. Okay? And essentially what we're doing here is that what I'm referring to as the length is, for example, in Ford, the length right now is 3 because that's the length of the models array, right? Now, if this were to grow, right, it'll be dynamic, and we will always get the correct average from that array. But we're not quite done yet, okay? So if we were to return the MPG now, we could get a decimal, potentially a decimal, right? So what we need is we need to call parse in on it to get a whole number, which is actually quite simple. Call parse in, which is a native JavaScript function. And now we can return the average MPG as a whole number, just like the EPA. Let's test our refactor function again in the browser. As you can see here, I have Honda with lowercase h. We get the same result. Let's try Ford. Okay. Let's try Toyota, all caps. Okay, and then let's try Tesla here, which will give the same result. All right. If you watch my other algorithm videos, you know that I strive for linear space and time complexity or better. Okay, O(n) solutions. So if you look at this function here, because I'm using a lot of JavaScript higher order function, these higher order function do have more overheads than pure loops. Okay, and if you look at this function, we have 1, 2, 3, 4, 5 different loops in here. However, these loops are not nested loops. Okay, so therefore they have similar terms, and therefore it's still an O(n) time complexity. And in terms of the space complexity, it's still linear, because that would depend upon, it's linear to the growth of the array itself, right? So we still have an O(n) solution here. Okay, even though, again, the higher order function do have slightly more overhead than traditional loops, but they, in my opinion, they are easier to read than loops, traditional pure loops. And there are multiple ways to solve this problem. Okay, some people use nested loops, which does not have a linear runtime. Okay, nested loops. Okay. So if you were to go with a pure loop solution, make sure you don't nest your loops. Okay. Okay. So I know it's been 2020 has been a challenging year. Now we are in a new year, and we can look to better things. And before I leave, I want to tell you, peace be with you. Shalom. Assalamu alaikum. Namaste. Good luck.